eet114, chapter 20, AC power for a resistive circuit. P equals VI. Note that VI, or the phasor magnitude, the RMS magnitude, also equal to VM times IM, which are the peak sinusoid magnitudes, divided by 2 equals I squared. R equals V squared over R in watts. The energy W equals VIT, where T is the period, or VI over F, where F is the frequency. Total power delivered to a resistor will be dissipated in the form of heat. Apparent power. S equals VI equals I squared Z equals V squared over Z. V is the voltage across the element in volts. I is the current through the element in amps. S is the apparent power in volt amperes. Z is the impedance of the element. P is equal to real power in watts. P equals S cosine theta. Power factor equals cosine of theta, or P divided by S. Theta is the phase angle between V and I waveforms, which is the absolute value of theta V minus theta I. Inductive circuit and reactive power. The net flow of power to the pure ideal inductor is 0 over a full cycle, and no energy is lost in the transaction. That's ideal. Q sub L equals V I times sine theta. V is the voltage across the element, phasor magnitude. I is the current through the element, phasor magnitude in amps. Theta is the phase angle of the element in degrees, usually degrees. So Q equals VI equals I squared times the reactance equals V squared divided by the reactance. This is all element based, and then W sub L is the energy dissipated by the inductor in joules equals VI times the period divided by pi, also equal to VI divided by the quantity pi times the frequency, or equal to Li squared. L is the inductance in henries, I is the current again, and then T is the period, F is the frequency. In a capacitive circuit, it's very similar. VIT divided by pi, VI divided by the quantity pi times the frequency equals CV squared, where V is again the voltage across the element, C is the capacitance, W is the energy dissipated by the capacitor, T is the period, F is the frequency. Now, the power triangle looks like this. Hypotenuse is S. The horizontal line, the axis is P, vertical axis is Q. Q sub L goes up, Q sub C goes down, like we've been talking about. And again, the bold is the vector form of the power. Unbold is the magnitude. So when I said S equals P plus Q, these are all vectors. S is in apparent power, volt amperes. P is real power in watts. Q is reactive power, and volt amperes reactive. So this is another form, plus JQL minus JQC. So QC goes down, QL goes up. Remember, inductor is L, looks more like a plus symbol, so it goes up. S is the square root of P squared plus Q squared. Power factor equals cosine of theta, P divided by S. Q sub T is the net reactance, and it is Q sub L minus Q sub C absolute value. To find the total PQ and S, find the real power and reactive power for each branch of the circuit. The total real power of the system PT is then the sum of the average power delivered to each branch. The total reactive power Q sub T is the difference between the reactive power of the inductive loads and that of the capacitive loads. The total apparent power is S sub T equals Square root of the quantity P sub t squared plus Q sub t squared. The total power factor is P sub t divided by S sub t.